Hi class, this is Dr. Karsten, and today we are going to be doing another review for comparing and adding fractions. And this is in preparation for our quiz because we were going to have the quiz last week, but then we had basically a 4-day weekend. So I'm going to give us a chance to do a couple more reviews before we do our quiz this week. And again, this is from Module 5, Grade 4 in Engage New York Math. So let's get started. Now, I also want to remind you that I am going to be doing a secret word or phrase in each of the videos, and you're going to have to tell me what that was. And so I will be starting with that. I'll give you the first part of the secret word or phrase in just a little while, and then I'll give you the rest of it at some later point in the video. So make sure that you watch it all the way through, and you can tell me what that secret word or phrase was, and just maybe there'll be some bonus points attached to that. All right, so let's get started. So the first thing I wanted to go over before we jump into doing this, and this was the practice review from last week. You're going to have a new one today. But I wanted to just really quickly remind you of some of the documents that you have to help you out. And the first one is this one, which is the Comparing Fractions review. And in this review, I talk about basically 4 different ways. But I say here that there are 3 main ways that we compare fractions. But there is a 4th thing that we do have to remember to do when we are comparing fractions, but it's a little separate. But remember that when the numerators are the same, I can just look at the denominators to see who is getting larger pieces. So if I have 2 pieces or parts, the numerator tells me the number of pieces or parts that I have. I can look at the denominator to see who's getting the larger parts or pieces. And remember that when you have a larger number, so 8 is a larger number than 3, the pieces are actually smaller. And you can see that right here, that the pieces are much smaller here than when I divide the entire thing into 3 pieces. And that's because the denominator is telling us the number of pieces or parts that make up one whole. So that's another thing for you to remember is that think about it the way we always consider it is, would you rather share a cake among 8 friends or 3 friends? Well, if you're only sharing with 3 people, or if 3 people are sharing together, everyone gets a much larger piece than when you're sharing among 8 people. So that was the first one. Numerators are the same. Look at the denominators to see who's, where are you getting larger pieces. I have 2 pieces in both those, but here my pieces are a lot larger, and you can see that. Okay, denominators. When your denominators are the same, and let me slide this up for us. When our denominators are the same, then you know that the size of the pieces is the same, and all you have to do is see who got more of those pieces. So clearly here, when all the pieces are eighths, and you can see my whole has been split into 8 pieces, here you only have 2 pieces, here you have 6 pieces. So 6 pieces is a whole lot bigger than 2 pieces. Now, we had another one, and that was when our numerators and our denominators are just completely different. So you have different numerators, different denominators. And then you had a few different options. You could compare them on a number line using benchmarks. You can use tape diagrams. Or, and this is the most reliable way, is to get common denominators by multiplying the fraction by the other fraction's denominator. There's actually another way that we can do it too, but I'm just going to stick with that as being our 3rd way for now. And then finally, and I hope you paid attention on the bottom of the page, there was a special note here. And it says if you have fractions greater than 1, turn them into mixed numbers to compare them. So for example, here I have 17/5. When your numerator is larger than your denominator, then you know that you have a fraction greater than 1. And so you'd want to convert that into a mixed number. And then you could compare it much more easily. And at that point, once you have mixed numbers, then you could actually use all the things that I just talked about. Okay, so now I'm going to give you our first part of our code for today. And the first part is blue, B-L-U-E, blue. All right, so then another thing that I pushed out last week to help us out, and I'm not going to go over the entire thing right now, is all about adding fractions. And there was this, and I will attach this again to some of our work as a resource. But here I talked about the 3 types of fractions that we might compare to determine which fraction is larger. One was fractions with the same denominator, and then we had, so that would be common or like denominators. Then we had fractions with different denominators that are related. so unlike related. And then we have fractions with different denominators that are not related or unrelated. And so the first thing that you would always have to do is decide what you had. And then I gave you this great sheet, and it gave you examples for each of these, and you can go through this one on your own. And then we had the next page, and it was a large piece of paper, or a large file here. We have another page, and then what I did was I gave you a third page that was basically a summary of the first 3 pages. And you can see the 3 different types of fractions here, how to figure out what they are, and then this was just a quick summary of how to solve them. Now, some of you may have gotten this. I pushed it out a little bit later. I attached it to this. But another way to think about it, and I just wanted to look at this really quickly, is when adding fractions, you should ask yourselves, and this is the 2-question method. First question, are my denominators the same or different? If they're the same, then just add the numerators and keep the denominator. If they're different, then you go to the second question. The second question asks you, are they related or unrelated? If they're related, then you can just turn one fraction into its denominator. So let me explain this with a visual aid for us. So here we go. So these two are different. 4 is different from 8, but they're related because 8 is a multiple of 4. And that's part of this. How do I know? Multiples. So what I can do is I can turn this fraction, I can convert it, I can decompose it into eighths. So if you have multiples of each other, 8 is a multiple of 4, you can take the smaller number, not necessarily the smaller fraction, but the smaller number, and decompose it into eighths, into the larger fraction's denominator. So that was part of this. So where was I? Here we go. So if they're related, then I just went over what to do. And if they're unrelated, then you can decompose both fractions by multiplying the fraction by the other fraction's denominator. I'm going to be showing you how to do that in just a minute. Excuse me. Okay, so we went over this. We went over the other sheet. So what I want to do right now, sorry, I just swallowed wrong. You'd think I've mastered this by now. Okay, so I'm going to go over the review from yesterday, the quiz review that we did yesterday, and then what you are going to do today is you're going to do a new one. And here's where you're going to put the special code. You already have the first part of it. So you're going to do adding and comparing fractions. Whew, practice quiz 2. So I'm going to go over practice quiz 1 right now. You already have comments in our Google Classroom on all of your work, so you can definitely go and check that out. But let's go ahead. And so remember, when we are adding, so first of all, sorry, it says add each pair of fractions. Remember to convert any fractions greater than 1 into mixed numbers. Okay, so the first thing we have to do is we have to decide what kind of fractions we're adding. So if I look here, I have 2/3 plus 1/3, and what I can see is that my denominators are the same. So all I have to do is add my numerators. So when your denominators are the same, just go ahead and add your numerators. And I'm going to rewrite it in the way that we're probably more comfortable seeing it, and you guys can do this too. So now you can see really clearly that I have thirds in the denominator. So I'm just going to add my numerators, and 2 plus 1 is 3. And I'm going to have 3/3. Remember that another way to think about this is you could say 2 apples plus 1 apple would be 3 apples. Well, similarly, 2/3 plus 1/3 is 3/3. So remember that it's kind of like the denominator when you're adding is a label. And you just want to hold on to that label. It's just telling you the size of your pieces. So you're adding 2 pieces plus 1 piece is 3 pieces. And what size are they? They're thirds. Okay, so now you should be noticing that 3/3 can actually be decomposed, sorry, not decomposed, but can be turned into 1. So we're actually really composing it. So either of these would be a correct answer. So again, for this one, what we had was we had same denominators. And I'm just going to abbreviate it for us. But we had same denominators. Another word for that is common denominators or like denominators. so let's go ahead and let's try another one together. So let's first take a look at this. Remember, the first step is we have to decide, are they the same or different, the denominators? And here I have 2 and I have 8, so they are clearly different. So the next thing that we ask ourselves is, are they related or unrelated? Now you can actually just treat everything like unrelated numbers, but you are going to get really big denominators then. So it's kind of nice if you can realize that for this example, 2 can actually be decomposed into 8ths because 8 is a multiple of 2. So these would be different denominators, and they are related because 8 is a multiple of 2. So I'm going to take that 2 and I'm going to I'm going to decompose it into 8ths. So how we do that is we take that 1/2, and we always show what we're doing. And then I want to turn that into 8ths because I need to get a common denominator. So 2 times what number is 8? And you know how I like to do that on the side. 2 times the number is 8. Or another way of thinking about that is 8 divided by 2 is going to give me that number, and that would be a 4. So 2 times 4 is 8. Whatever I do in the denominator, I have to do in the numerator. 1 times 4 is 4. And you know, now that I look at this, I can really easily see that 4 is half of 8, so I do know that this is equivalent to 1/2. But regardless, I know that 1/2 is equivalent to 4/8 because we just did the math. So now what I want to do is I want to take this 4/8 and I want to substitute it in for that 1/2. I'm going to keep my 3/8 because now I have common denominators. So I have 4/8 plus 3/8 is 7/8, and that's going to be your answer. 7 is smaller than 8, so my fraction's good to stay. So again, what kind was this? This was different but related. So different denominators, but they were related. All right, so let's take a look at another one. So for the next one, again, our first question is, are they the same or different? And I have 5 and 4 in my denominators. Definitely different and also definitely not related. These are unrelated. 4 cannot be decomposed into 5 and vice versa. So the rule that we're going to use for this one again is that we are going to multiply the fraction by the other fraction's denominator. So let me first do 2/5. So I'm going to take 2/5. And again, what I want to do is I want to multiply it times the other fraction's denominator. So since I'm working on 2/5, I'm going to multiply it by the other fraction's denominator, which is 4. And I'm going to put the same thing in the numerator. So my denominator and my numerator have to match. So now I can just multiply across. Now when we're multiplying or dividing, we do both the numerator and the denominator. It's different than adding and subtracting. So 2 times 4 is 8, 5 times 4 is 20, and now what I know is that 2/5 is equivalent to 8/20. So I can take this 8/20 and I can substitute it in for 2/5. And then I'm going to be adding 3/4 to it, but I can't because 20 and 4ths does not go well together. They don't work together. So what we have to do now is we have to decompose 3/4 in the same way. So I'm going to take 3/4 and I'm going to multiply it by the other fraction's denominator, which was 5. So again, I'm taking 3/4 and I'm multiplying it times the other fraction's denominator, which was 5. 3 times 5 is 15. 4 times 5 is 20. So now I can take this, which I know is equivalent, 15/20 is equivalent to 3/4. So let's take that 15/20 and let's move it over here and substitute it in. And now what's great is that we have common denominators. They're the same. We have 20ths, and that's again going to be our label. So now I am trying to add 8/20 plus 15/20, or 8 of those pieces plus 15 of those pieces. And that is going to give me, and I keep switching colors here, guys. So 8 of those pieces plus 15 of those pieces is going to give me 23 of those pieces. And now what I can do with those 23 pieces is that 23 is bigger than 20. So this is a fraction greater than 1. I can pull out 1 from that. And what I know when I'm dealing with 20ths in the denominator, I know that 20 20ths is equal to 1. So I want to pull out 20 20ths. So I had 23 pieces. I put 20 here. That means I have 3 left. So what happens is this 20ths becomes 1, and we end up with 1 and 3 20ths. And that's going to be our answer for this one. This is also an answer, just so you know. So this actually is also an answer, but the rules did say that we wanted to convert any fractions greater than 1 into a mixed number, so this would be the correct answer for this problem. So again, my denominators were different, so I had to take the fraction and multiply it times the other fraction's denominator. So I took 2/5 and multiplied it times 4. I got my answer. I did the same thing for the other one, 3/4, multiplied it by 5/5, got 15 20ths. And then I could substitute these two fractions in over here. So instead of having 2/5, I would have 8 20ths. And instead of having 3/4, I would have 15 20ths. And now I can go ahead and add. I got 23 20ths, and now we could break that down into 1 and 3 20ths. All right, so let's go ahead and let's take a look at some of the comparing fractions. So again, for this one, we need to write greater than, less than, or equal to in between the two fractions. Oh, I forgot to identify this one. Sorry about that. So this one was different denominators, and they were unrelated. All right, so let's go ahead and let's do a new one. So let's take a look at A. So first we have to identify the types of fractions that we're comparing. And here again, we have fractions that have the same denominator. When fractions have the same denominator and we're comparing them, I now know my pieces are all the same size. Where do I have more of those pieces? 7. 7 is definitely a lot more than 3. There we go. Next one. So here we have 4/9, and I'm going to rewrite this the way that we're more comfortable with. 4/9 and 4/5. So when I look at this one, I can see that my numerators are the same. When my numerators are the same, I can go to the bottom. It means I have 4 pieces of each of these. I want to know, are 5ths bigger pieces or are 9ths bigger pieces? Since I have the same number of pieces in my numerator, I can just figure out which one has bigger pieces. And what we know is that 5 in the denominator means that each piece is larger than 9 in the denominator. This is like a cake shared among 5 friends. Oh, you guys can't even see it. Sorry. This is like a cake shared among 5 friends. This is like a cake shared among 9 friends. These friends, everyone's going to get a way bigger slice. And you could draw a tape diagram. You could do whatever you wanted to show that. I can really quickly model it with a tape diagram. So if I wanted to do 5ths, there we have it. But if I'm doing 9ths, it's going to be a whole lot tighter. Oh my goodness, I feel like I'm totally messing this up. Sorry guys. I have to cut this up into 9ths, and I haven't done 9ths in a while. I should have done 3rds first. So I'm going to do another one for 9ths because I don't want to mess it up even more. Oh, actually, I could have made it work. There we go. And so here you can see if you had 4 of these 5ths, 5ths are a lot bigger than 9ths, each one of them. And then I need 4 of these 9ths. There we go. And you can see 4/5 is a lot bigger than 4/9. All right, and that's because each one of those is bigger. So for this one, I would go ahead and show that 4/5, because 5 is a smaller number, but it means each piece is bigger. So 4/5 is larger than 4/9. All right, we just have a couple more to do, and then we're done for today. Okay, so let's figure out what kind of problem we're looking at. So this one says 3/4 and 4/5, and I can see that my denominators are not the same and they're not related, and I can see my numerators are also not the same. So since my numerators are not the same and my denominators are different, so that's that first question, same or different, they're different, And then I figured out that they were unrelated because 5 is not a multiple of 4. So what I'm going to do is I am going to go ahead and I am going to, sorry, I just wanted to look at something for a second. Sorry. Okay, so I'm going to go ahead and I am going to multiply the fraction by the other fraction's denominator. And I'm going to do that twice, once for each of them. So again, because they are different and they are unrelated. So what I want to do for this one is, I guess I was working with red, it works pretty well. Let's take that 3/4 and let's go ahead. And again, you could actually do a tape diagram for this. You could do a number line for it. But I find that I get the most accurate answers if I go ahead and I decompose these so that I have common denominators. So I'm going to start with 3/4. And what I want to do is I want to multiply it by the other fraction's denominator, which for this one is 5. So 3 times 5 is 15, and 4 times 5 is 20. So now what I can do is, I know that 3/4 is equivalent to 15/20. I can actually put 15/20 here. They're the same. So now what I want to do is I want to do the same thing for 4/5. So I have 4/5, and I'm going to decompose it by multiplying by the other fraction's denominator. So here's 4/5, the other fraction is 3/4. I'm going to multiply it times 4. 16/20. And you can see now we have common denominators. And now I can actually just look at it to figure it out. And what I see very quickly is that the sizes of my pieces are now the same, but here I have 15 and here I have 16. So clearly 16 is greater than 15, which means that 4/5 is also greater. And I can write that in too. All right, we are in the home stretch here, gang. One more. So let's do this last one. And this is that other kind of problem. So for this one, what I can see is that I have fractions greater than 1 because my numerator is larger than my denominator. So let's go ahead, and the first thing I want everyone to do is to take 14/3, and I want us to turn it into a mixed number. So what we have to pull out of this one now, since we have a 3 in denominator, I know that 3/3 is equal to 1. I want to pull out all those 1s. So I want to pull out 3/3 here, 3/3 there, 3/3 here. So I have 3, 6, 9/3 so far. 3/3 here, which is up to 12, but I'm not going to make it to that 14. So I have 3, 6, 9, 12/3. I need 2/3 more. And now what I can do is I can combine all these. This is a whole, this is a whole, this is a whole, and this is a whole. So I have 4 and 2/3. Okay, so now we have to do the same thing with the other one. So let's take 7/2. So I'm going to take out, so since my denominator is 2, I know that 2/2 is equal to 1. So I'm going to take out 2/2. I'm going to take out another 2/2. So that's 4/2. 2, 4, 6. And now I just need 1/2 more to get to 7. And now I can combine all of these, because this is really 1 whole, 1 whole, 1 whole, or 3 wholes, and a half, because I have to hold on to that half. Okay, so now it is so easy for me to figure out which one is larger. Clearly, 4 and 2/3, 4 is bigger than 3, which means that 14/3 is the larger number. All right, so I hope that this was helpful. And oh, you know, I just realized I forgot to give you the second piece of the code. The second part was bury. So the first part, well, you have to go back and find it. So just remember the second part is bury. All right, so gang, make sure, so let me just remind you of what you're going to be looking at. So you should watch this video. You should take a look at the resources comparing fractions and adding fractions. And then where did I put it? Here it is. And then you are going to do something very, very similar to what I just modeled. So you're going to do the adding and comparing fractions practice quiz number 2. And this is where you're going to write your special code. This is where you're going to work. You just have 3 questions again that you're adding, very similar. and then you're going to go into comparing the following fractions. Let me just remind you, also make sure that when you get fractions equal to or greater than 1, turn them into fixed numbers, please. And then you do have this page where you have, let me see, a whole bunch of questions, but a lot of them are super easy. Remember, first check to see, do we have common numerators or do we have common denominators? Let me see if I can find, oh yeah, we definitely have a bunch. There's common denominators. Oh, I found a whole bunch of common numerators. So those are going to take you about 30 seconds to answer those ones. But anyway, if you have questions, I will meet you in our Google Classroom. I hope everyone has a great day. And don't forget to include your special secret code. All right, everyone have a great day.